Oh, got that malted milk balls in my throat. All right, here we go. Okay, so first of all, I'm a big fan of this problem. Second of all, this is a triangular prism. Do you recognize that? And so, but what the weird thing is, it's the base that's changing. So, like a triangular prism has a triangle for the base and then rectangles for their sides. So, the volume of a prism is the base area times the height. Okay, so no, that's for pyramids. That's for things, people get them confused all the time. Pyramids have triangles for the lateral sides. Prisms have the top and the bottom are the same shape, and then the lateral sides are rectangles. But so many kids get triangular prisms confused with pyramids. Pyramids come to a singular point.
And
Okay?
then the pyramid is a square bottom and then the dome is
Well, there's many types of pyramid, but yeah, it can have it's a square pyramid. I could draw you an octagonal pyramid. You know, like what?
Is it like
It looks like a big top, like a circus tent. You know what I'm saying? Okay. All right, so I'm going to start over. Now, so let's draw a cross section of the base. Take a look at it. This is 3. Okay. It says that these are congruent, but it doesn't tell us what they are. And then this is 3. I know I hear it's on the outside, but I could draw it right here, and it's the same thing. Does that make sense? So we're going to need to know the area of this thing. And then if I drew another picture of it, this is 12, okay? The area of our base, remember, this is the base, is changing. So the volume is going to be the area of the base times 12. 12 is always the height. I know that doesn't look like the height, but that's because you're not familiar and comfortable with pyramids. Sorry, with prisms. So you should see this thing I just colored. That is actually this.
so that's considered from bottom when it's standing
On its basis. On its basis.
So like
bases are parallel.
So where it says that each feet, like the little variable,
Yep.
is that then like the length of the base?
So the H would be so like look, there's a moment where this is H and that's H. Like right now it's not 3 yet. In fact, it won't be 3 till it gets totally filled up. Okay? Does that make sense? So now let's dissect the area of the base. Okay? So if we just have a similar triangle, it's H and H, right? What's the area of a triangle? What is it? All right, so our base area could be considered H squared over 2. Does that make sense? So now we got our volume in terms of our H. I told you that most of your questions we're going to be from geometry. We haven't done any calculus yet.
Is it? It's in terms of h because you're trying to find the rate of h.
Yeah, we want to find dHdt. Maybe I should have started with that. Okay, so volume is going to be h squared over 2 times 12. So our volume is going to be 6 h squared. Okay, now let's read. The water is being pumped at 2 cubic feet per minute. What's that? What do we measure? What mathematical thing is measured in cubic feet? Okay, and if we're going to do cubic feet per minute, and it's changing,
So it's like dv over.
there you go. Now you're doing calculus. So dV over dt equals 2. Every minute, we put 2 cubes of water that are 1 by 1 by 1 into this thing. Well, it's flowing constantly. Does that make sense? But the volume or the height is going to be changing at a different rate. All right, here we go. We're getting there. So now, can you take the derivative of that? What's the derivative of V?
Dv over.
That's right. It's 1 dV dt. Okay, equals. Now we want the derivative of this right side with respect to t. So we're still going to multiply by a differential.
So is it 12
So it's 12.
dh?
Well, we still have an h.
12
12h.
h over.
The only time we don't take the differential is if we're taking the derivative with respect to that letter. Which is why, like in normal derivatives, it's y equals x squared. You're finding dy dx. Dx is on the bottom. You don't multiply by dx
So
dx.
if dh was on the bottom, the h wouldn't be there like this.
No, if we were taking the derivative of this thing with respect to h, then it'd be 12h times dh dh. You wouldn't write that down. Unnecessary. Does that make sense? We're taking the derivative with respect to time. And all this will make, this is why I love intro to calc. Because you need another shot at going back through it. And it'll make so much more sense next year once you take physics too. 2 years for you. Okay? Ready? So now we probably know all these things. Part A, dV dt is 2. How fast is the water when H is 1.1? Sweet. So dH dt is 2 divided by 12 divided by 1.1, right? Alpha y equals enter. 2 divided by 12 times 1.1. No. Okay, and then if I wanted to, I could go math, turn that thing to a fraction. Come on. 5/33. What did they have? 5/33. Okay. And then for B, all you do is so now for part B, now they're giving you dH/dt. The water is rising at 3/8 per minute. You know what the giveaway is? It's inches per minute now and not cubic inches per minute. This is where like the units really can help us. So dH/dt is 3/8. Find dV dt at h equals 2.4. Oh, so now we have dV dt. It's 12 times 2.4 times 3 divided by 8. And I promise you that'll give you 9/10.
Okay.
Boom.